Welcome to Building Type-Safe GraphQL APIs with Prisma. Before I get into this talk, I'd like to begin with a question to set the context. When building database-backed GraphQL APIs, how do you manage and evolve the two schemas, those being the GraphQL schema and the database schema? GraphQL's power lies in its concise and declarative schema, which defines the API's capabilities. Here's the thing though, if you're using a relational database like Postgres, you essentially end up with two schemas, the database and the GraphQL schema. And typically these schemas don't map one-to-one. For example, if you're persisting password hashes in your database, you probably don't want to expose that field over your GraphQL API. This begs the question, how do you manage and make sure that you have the full control over your GraphQL API when it's backed by a database? This can be a challenge because essentially you end up with these two schemas, and adding new features typically involves changes to both the database and the GraphQL schema. And so today you will learn about the ways that Prisma helps you build these GraphQL APIs and manage the two schemas. Today's talk will be split into three parts. In the first part, I'll set context by recapping the reasons for using GraphQL in the first place. In the second part, we'll see how Prisma helps you work with your database and the type safety it provides. And finally, in the last part, you will learn how to build GraphQL APIs with Prisma. Wait, but why GraphQL? So why would you build a GraphQL API? Well, the first reason is that GraphQL provides a contract, and that is the GraphQL schema, and it serves as a form of documentation. But beyond that, it also allows for a great developer experience and provides a lot of a basis for a lot of automated tooling, which leads me to the second point, automated tooling that enables a lot of these new workflows. And so you have a lot of these GraphQL code generators that generate TypeScript types from your GraphQL schema, and you have things like GraphQL Voyager that allow you to visualize your GraphQL schema. So essentially the schema is parsable, and then using an abstract syntax tree of your GraphQL schema, you can do a lot of things. Then we have the multiple clients consuming from the same data source. So imagine that you have an iOS, an Android app, and a web client, and each of these clients is developed independently by a different team. By having a GraphQL API, essentially you allow each team and each client to consume the exact data that it needs. It's also easier to roll out non-breaking changes. Rather than versioning, a common approach in REST APIs, additive non-breaking changes allow for this continuous evolution, and this is really the approach that is encouraged with GraphQL. And finally, as I mentioned, in the context of multiple clients, you avoid this overfetching and underfetching problem with your data, because you can choose in your GraphQL queries the exact data that you need. This brings us to Prisma. So what is Prisma? Prisma is a next-generation ORM for TypeScript and Node.js. It supports Postgres, MySQL, SQLite, SQL Server, and MongoDB, which is currently in preview. And essentially, it helps you as an app developer to build faster and make fewer errors with type-safe database access. And type safety is going to be a very, very important theme throughout this talk. So the core goals of Prisma are essentially to boost productivity by letting you as a developer to query data in natural and familiar ways. It also increases confidence with type safety, auto-completion, and a robust query API. The Prisma ORM consists of three tools. The first one is Prisma Client, a type-safe and auto-generated client which you use in your application to issue queries to your database. The second one is Prisma Migrate. That is a declarative data modeling and database migrations tool. And finally, Prisma Studio, a modern and intuitive GUI for your database. So let's take a look at that. So at the core, at the heart of Prisma is the Prisma schema. And the Prisma schema is a human-readable single source of truth for your database schema and your application models. It enables you to essentially model your problem domain. And as we'll see, it also provides the foundation for the type safety that Prisma provides. And so here we have an example model, and we have an ID field of type int that is the primary key. It also is auto-incremented by default. You also have the email field that has a unique constraint. We also have the name field of type string, and as you can see, the question mark denotes that it is optional. And the great thing is that essentially you define this Prisma schema, especially if you're starting in a new project. And Prisma Migrate then helps you to automatically create these SQL migrations for you from this schema. Now let's take a look at how relationships are modeled, because that's one of the core pillars of graphs and really working with relational databases. You want to be able to define connections between different parts of your data, different entities of your data. And so here we define a one-to-many relation between the user model and the post model. Now it's worth pausing here for a moment and reminding that each model in the Prisma schema essentially maps to a database table, and each field maps to a column in that table in the database. Now, you may notice this relation is essentially defined with a single foreign key on the posts, that is the author ID. And that author ID essentially is how this would be created in the database. You may also see these two fields, the posts of type post in the user model, and also the author of type user in the post model. And it's important to note that these two fields are only used for the generated Prisma client. That is how you actually access the relations when you're querying data, but these are not created in the database, because all you need to define the relation in the database is this foreign key, which is denoted by the author ID. Now, with this relation that we've defined in between these two models, you can simply generate a migration, and this would be done with this Prisma migrate dev command. And so here we have basically the output that is created by Prisma migrate based on the changes that we made to the Prisma schema as we introduced this post model. Now, I spoke a lot about confidence and productivity, but let's see what it looks like in practice. The following shows a Prisma client query that creates a user and a related post. I spoke about the two benefits, right? And this is how Prisma achieves this. First of all, auto-completion. You may see that as I'm typing this query, I actually get the immediate feedback of what fields can I actually add to this query. You will also maybe notice that Prisma focuses on queries rather than classes to avoid these complex model objects that are very common with active record ORMs. Prisma Client simply exposes these methods that return plain old JavaScript objects, and these are all fully type safe. So based on the query that you create, a type will be inferred. So in this case, Hannah will actually have all of the properties of the user that was created, and also the post that was created in this single query. And of course, these type-safe database queries, they can be validated at compile time. So when I try to add an integer as the email, you can see that I immediately get that type error. And this exemplifies this immediate feedback loop that you get. Finally, Prisma Studio. With Prisma Studio, you simply type npx Prisma Studio in your terminal, and then you have a GUI for your database. And you can use that to search, to edit, and to create new rows in your database. And here I show how to explore related posts, how to edit a post, and how to even create a new post that is associated with an existing user. So as we saw, Prisma allows you to interact with your database, and it's worth pointing out at this point, before I get into GraphQL and Prisma, that Prisma is API technology agnostic. You can use it to build REST APIs, you can use it with gRPC, and of course, as we'll see in this part, how it works seamlessly with GraphQL. So let's take these ideas of Prisma and type safety and apply them to GraphQL. And we'll start that by looking at the anatomy of a GraphQL server. And so a GraphQL server consists of two components. The first is the GraphQL server, which serves it typically the GraphQL API, that is, over HTTP. And it's worth noting that GraphQL is transport layer agnostic. And so you don't have to use HTTP as the transport layer, but that is probably the most common transport layer that people use because HTTP is so broadly used for web technologies. The second part is the GraphQL schema. And the GraphQL schema essentially defines the API operations and the data structures of the API. And concretely, for you as a developer, what does that mean? Well, it means that it includes the actual schema that you define. And we'll get to that in a moment, how you can create that schema. And the second thing is the resolver functions. And these are the functions that actually return the data, fetch it from wherever it may be. In our context, it's going to be a relational database, but of course you can fetch data from anywhere, including third-party APIs. So how does this GraphQL schema look like? Well, first of all, it's often called the SDL, the schema definition language. And here we have this very simple schema with two type definitions. We have this user type, which contains two fields. The ID field that is non-nullable, that is denoted by the exclamation mark, and the name field, which is optional and is of type string. Then we have the query type. The query type is this very common root type that you have in GraphQL schemas, and that essentially exposes all of the query operations that you can issue against the GraphQL API. And here we just have one query type called users that returns an array of users. Now, it's worth pausing here and reminding that GraphQL encourages the schema-driven development. And in addition to that, it's worth noting that each of these fields in the types will have its own resolver. Now, you probably at this point may notice a lot of similarities between the GraphQL schema and the Prisma schema that we looked at before. And we will get to how the two relate in a moment. But how do you construct this GraphQL schema? Essentially, there are two main approaches to constructing the GraphQL schema. The first one is the schema-first approach, as you can see here on the left. It's also often referred to as the SDL approach, where you essentially write a GraphQL schema using the GraphQL schema definition language, and then write these corresponding resolver functions in your programming language. The second approach that we have is called the code-first approach, where you programmatically create both the schema and the resolver functions in your programming language. And while the schema-first approach is easier to get started with, it comes with some inherent drawbacks that can make development difficult as your application grows in complexity. Now, for the example of using the code first, I use this library called GraphQL Nexus. Prisma also contributes to this library. And GraphQL Nexus is a code-first, type-safe GraphQL schema library for JavaScript and TypeScript. And it is data agnostic, so you can use it with any data access layer. And as we'll see, there's also an additional plugin that essentially bridges between GraphQL Nexus and Prisma. So let's talk a little bit about some of the trade-offs when using the schema-first approach when comparing that to the code-first approach. When getting started with GraphQL, there's a lot of cognitive overhead to learn all of the different tooling. And when using this schema-first approach, you have to rely on specific tooling for each one of these problems that are mentioned here. Inconsistencies between your schema and your resolvers, modularization, importing, composition, and tooling and IDE support. And the main benefit of using this code-first approach is that you lean on all of the tooling that you're familiar with in your programming language. And so all of these challenges are essentially solved by primitives in your programming language that you're already familiar with. Now let's get into a demo. And in this demo, I want to do a couple of things. First of all, I want to demo what type safety means in the context of just Nexus.js without introducing any database. Then we will look at how essentially from Nexus the GraphQL schema is generated, because we're defining it using code, but we still have a GraphQL schema. We will also take a look at what it means to introduce Prisma into a Nexus GraphQL schema. And then we'll take a look at this plugin that makes it easier for you to take your Prisma schema and then project that onto the GraphQL schema. So let's get into it. Here I have Nexus code that essentially defines two types. We have this user object type, which defines the three fields, the ID, the name, and the email, where email and ID are non-nullable. And then we have the query type. And the query type has the single type users, which returns a non-nullable list of users. And as you can see, we already see this squiggly line here. And if I hover over this squiggly line, you may see that I'm getting an error. And the reason is that basically email should be declared here. And as you can see, I made this error, of course, deliberately in order to showcase what happens when I remove that. Now, at this point, it's worth also pausing to sort of speak a little bit about how Nexus pulls off this trick. Nexus has this really unconventional concept called reflection, and it is used in order to provide the type safety that you get from Nexus. And so what is reflection? Essentially, when make schema is being called, and it is being called by the module that imports these types, make schema, what it will do is it'll generate two artifacts by looking at your Nexus code. The first artifact is the GraphQL schema, and then the second is it'll generate TypeScript types. So essentially you're writing JavaScript or TypeScript code in this case that is then used by Nexus in order to generate the GraphQL schema and also these types under the hood. And the reason that it's unconventional is because actually when we run the TypeScript compiler in order to generate these two artifacts, we don't want to type check because we want the type checking to happen a step later. So I'm going to run here a command called a command that I have configured called dev nexus. And what this does is it essentially calls the TypeScript compiler, but it tells the TypeScript compiler only transpile, but do not type check this. And the reason is that VS Code will already do the type checking based on the generated types. And so the moment that I change this to email, you can see that the type error goes away. And that is because VS Code was picking up on the types in the background that were generated by this command and then did the type checking. And once I fixed that, it was all sorted out. Okay, so that was a little bit about Nexus and how type safety works in Nexus. And essentially, the main thing to remember here is that you get this type safety out of the box. You have just this initial configuration where you have to set up the command with transpile only. And then you sort of, as you're writing your GraphQL schema, essentially you get this type safety between the object types that you're defining and all of the resolvers. So in other words, both the inputs and the outputs from your resolvers are type checked to match the declared type. Okay, so that was that, but here I'm obviously only returning a single array of objects that doesn't involve any fetching from the database. And sort of the holy grail of type safety would be to have end-to-end type safety from your GraphQL schema all the way down to your database. And so how can we do that? Here I have another example, and I'm going to just import that so that it's picked up by the compiler. And so the moment that I save this, you can see that it's been modified and it will transpile it in the background. So here I'm taking the same idea of using Nexus to define these object types in the queries, but here I define also an additional object type called post. And so essentially we have these two object types, user and post. And here I just define whether they're nullable based on whether they're optional in the database. And then we have the relation resolvers. The relation resolvers are very important because that's where the Prisma data loader comes in, and that's also where the n+1 problem comes in. And should note that Prisma comes with a built-in data loader, so that means that you don't have to worry about the n1+1 problem. And so here all we do is, when we're trying to resolve the posts for a given user, we use this Fluent API, we call it, the Fluent Relation API, in order to first get the user and then get the related posts. And so if we call the users query, which returns multiple users, and for each one of these users, it has to fetch multiple posts, that's where the n+1 problem shows up. And this is where Prisma will essentially look at all of these calls and batch them into a single database query. And the same thing happens here with the post type. And of course, I should mention that we also have this query type here that has the users, that's the actual query name, and the type refers to this user type defined here. And that just makes a call to Prisma client to fetch users. So that was sort of the type safety that we get here. And you may notice if I actually forget to fetch the posts, because Prisma is type safe out of the box, then the inferred type will not match the expected return type from this resolver function, and that's why we get this type error. And so I'm going to bring that back. So, okay, so that was Nexus. We just saw what Nexus looks like, and then we saw what it looks like to introduce Prisma into Nexus. Now let's take a look at how this Nexus Prisma plugin can help us. And so before I do that, I also want to show that we have the GraphQL schema that is generated for us. And so, for example, if I remove this name field and I click save, you may see that it's been removed also from the GraphQL schema. So I'm going to bring that back. And now I want to get into the Nexus Prisma plugin, which saves a lot of trouble. So the Nexus plus Prisma, that sort of gives us Nexus Prisma. And what it does is it essentially takes the core idea of type safety that is given in Nexus and Prisma individually, and then makes a bridge between two. And the main benefit is that it saves a lot of boilerplate. You don't have to define these relation resolvers. And you get this sort of the built-in data loader, and it gives you still full flexibility over how you design your API and which database fields you choose to expose. And of course, you get this end-to-end type safety all the way from the database schema to your resolvers. And so that means that if you change a database schema field in Prisma, you will immediately get a type error if you hadn't updated your GraphQL schema. Now, of course, you don't have to use this as I showed, but it's a really nice tool. And I mentioned already all of these benefits, so let's go back to the code. So here I have the final example that I want to show today, and you may notice that I don't actually have to define whether these fields are nullable and their type. What happens is that Nexus Prisma is essentially a generator for your Prisma schema that generates these types and also the resolver code. And then those are then imported here from Nexus Prisma. And then instead of having to define all of the relation resolvers manually, I just sort of import them and I choose which fields I want to project. Now, if I quickly open up the Prisma schema, you may see that I have this password field. And of course, as I mentioned in the beginning, this whole challenge of syncing between the two schemas, GraphQL and the database schema. So theoretically, I could add here user.password, and that would be valid. In fact, if I look now at the GraphQL schema, you will see that, one moment, I just need to make sure that I'm importing the right example. And so going back to the example that we were looking at where I introduced the password, if I now look at the GraphQL schema, we can see that we have this password field that is non-nullable. But of course, we want to remove that. And so that was the main idea with Nexus Prisma. It saves you a lot of boilerplate. And also, I just want to quickly look at the Prisma schema and just mention that this is the generator that essentially generates all of these types based on your database schema. So that was Nexus Prisma. And as I mentioned, you have this generator and you can choose which fields you want to project. And again, this is how sort of the GraphQL schema is generated for you and how you save a lot of this boilerplate. As I showed you, you don't have to define these relation resolvers. You simply import it from the generated Nexus Prisma code. And so now it's worth sort of making a note that Nexus is responsible for constructing your GraphQL schema, but you can use that with any GraphQL HTTP library that you're used to. You can use it with Apollo, with Fastify, with Mercurius, with Express GraphQL, and even with the up-and-coming star GraphQL Helix. Now, I've riffed so far a lot about the benefits of Nexus and Prisma, but obviously the ecosystem is large and Nexus isn't the only approach to building GraphQL APIs with Prisma. And here are some other libraries that can help you build GraphQL APIs with Prisma. There's the Prisma AppSync generator. If you just want to generate a fully fledged GraphQL API and deploy that to AWS AppSync, there's Type GraphQL Prisma, which is a plugin if you prefer the classes approach to constructing GraphQL schema, an alternative sort of code-first approach. There's Redwood, which is a full stack framework based on Prisma, React, and GraphQL. There's Keystone, a CMS based on Prisma that also exposes a GraphQL API. And finally, Application, which is a low-code generator that gives you also a fully fledged GraphQL API and uses Prisma. Now, as I've reached the end of this talk, I'd like to summarize by going back to the opening question, which was, when building these database-backed GraphQL APIs, how do you manage and evolve these two schemas? And while there are many, many approaches and solutions to this problem, I think the key idea that introducing type safety to this kind of workflow, especially across the database and the GraphQL boundaries, makes it easier to manage and significantly improves your developer experience. So Prisma helps you be productive with managing your database schema and gives you this type-safe access at zero cost because it's all generated for you. Nexus does the same thing with type safety for your GraphQL schema, and Nexus Prisma is sort of like the cherry on top that reduces a lot of the boilerplate when using the two together. And so if you're interested in learning more or order some free stickers like the one that I have here, just go to prisma.io/GraphQL and you'll be able to order these stickers. And on that note, I'd like to thank you for listening today. I was Daniel Norman, developer advocate at Prisma, and I'd be happy to answer any questions if you may have. Thank you.